In 2003, from a quiet strip of Florida's coastline, a rocket gently lifted into the sky. Its destination was Mars. On board was a small machine, a rover that would quietly reshape what we believed was possible. Her name was Spirit. Officially, she was known as MER-2, one of 2 robotic twins in NASA's Mars Exploration Rover mission. But to the world, she became something much more, a quiet symbol of endurance. Spirit was never meant to last long. Her expected mission? Just 90 souls, about 3 Earth months. But she survived for nearly 6 Martian years. She wasn't designed to face the bone-chilling Martian winters, yet she lived through 3 of them. She wasn't built to endure suffocating dust storms, but she kept going. And hills, craters, those weren't in her plans, but she climbed them anyway. From the very beginning, Spirit had a mission: to act as a robotic geologist, a lone explorer searching for traces of ancient life. Working alongside her twin, Opportunity, she formed the heart of NASA's bold plan to unlock the Red Planet's deepest secrets. That plan, the Mars Exploration Program, had 4 defining goals. 1. To discover whether life ever existed on Mars. 2. To understand the planet's climate. 3. To study its geology. And 4. To prepare the way for human explorers. Spirit would be key to all of it. Her job was to study the soil and rocks, searching for signs that water had once shaped them. A silent clue that life might have been there long ago. With no humans able to make the journey themselves, Spirit became their eyes, their ears, their hands. To fulfill this task, Spirit carried a carefully designed set of tools. She weighed about 185 kilograms, roughly the size of a golf cart, and came equipped with powerful panoramic cameras, navigation systems, a thermal emission spectrometer to analyze minerals, and 2 HazCams, short for hazard cameras, to watch her surroundings. Her robotic arm carried even more instruments: a Mossbauer spectrometer to detect iron-bearing minerals, an alpha particle X-ray spectrometer to study chemical elements, a microscopic imager for extreme close-ups, a magnetic dust collector, and the rock abrasion tool, a kind of Martian grinder designed to peel away the outer layers of stone and reveal what lay hidden within. But her body held something far more human. Embedded within her design were fragments of steel, pieces taken from the fallen World Trade Center. They were used to shield her internal wiring. She carried with her not just science and instruments, but the weight of memory, of loss, and of hope. And her name, Spirit, that came from a child. A 9-year-old girl named Sophie Collis, who once lived in an orphanage in Siberia before being adopted in America. Her words, written for NASA's naming contest, were simple, but unforgettable. I used to live in an orphanage. It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there. In America, I can make all my dreams come true. Thank you for Spirit and Opportunity. And with those words, Spirit had a name. A mission? A soul. She was ready to begin her journey. The journey from Earth to Mars took Spirit nearly 7 months. But the most dangerous part came right at the end. The landing. Touching down on another planet isn't just hard, it's unforgiving. NASA has a name for it, the 6 minutes of terror. That's how long it takes a spacecraft to go from streaking through the Martian atmosphere to a full stop on the surface. On January 4, 2004, Spirit reached the top of Mars' atmosphere at almost 19,000 kilometers per hour. 15 minutes before entry, the spacecraft detached from its cruise stage, drifting in silence inside a protective aeroshell. As Spirit plunged toward the red planet, friction began to ignite the heat shield, raising its temperature to a blistering 1,600 degrees Celsius. At about 6 kilometers above the ground, the parachute deployed, violently slowing her fall. Half a minute later, the bottom of the heat shield was jettisoned. Spirit then began to lower on a tether, carefully unspooling from her shell. Her onboard radar scanned the Martian terrain below. It was now up to the computer to decide precisely when to fire the retro rockets. Just 5 seconds before touchdown, the airbags inflated around Spirit. But why airbags? Because Mars' atmosphere is incredibly thin, just 1% the density of Earth's. A parachute alone couldn't slow the descent. Spirit hit the Martian surface at 14 meters per second. She bounced, then again, and again, nearly 30 bounces in all. Had even one bounce landed on a sharp rock at the wrong angle, it could have all ended. But Spirit got lucky. The airbags held. The terrain was kind, and when the bouncing finally stopped, Spirit had come to rest just 250 meters from her first impact point. The landing was complete. She had survived the most dangerous 6 minutes of her life. And now she was on Mars. Her descent had carried her into Gusev Crater, a vast ancient impact basin that scientists believed may once have held a lake. Her new home was harsh, rocky, and blanketed in Martian dust, a landscape filled with secrets, waiting patiently to be discovered. As the Martian dust finally settled, Spirit began to unfold. She extended her wheels, unfurled her solar panels, and gently rolled down the lander's ramp onto the soil of another world. This was it. Spirit's first moments as a truly independent explorer on Mars. Her first task, a panoramic survey of the alien terrain around her. Not just beautiful images, but vital, high-resolution data to help NASA's scientists choose where she would roam next. Using her panoramic camera, the PanCam, Spirit stitched together an extraordinary view. 4 images high, 3 wide, captured in black and white through 13 different filters. Combined on Earth, they formed the highest resolution color photo ever taken on another planet at that time. What it revealed was hauntingly beautiful. A raw Martian landscape, scattered with rocks in every shape and size. And in the distance, hills rising on the horizon like frozen waves in a sea of dust. Spirit's landing site was named Columbia Memorial Station in honor of the 7 astronauts lost aboard the Space Shuttle Columbia. The nearby hills would later bear their names, Anderson, Brown, Clark, and Husband Hill among them. Close to the lander, a circular depression caught the scientists' attention. They called it Sleepy Hollow. Just 12 meters away and 9 meters across, it was the perfect first target, a chance to peer beneath the surface of Mars. Spirit got to work. But then, silence. On January 21st, just 17 sols into the mission, communication abruptly stopped. NASA's Deep Space Network reached out, but Spirit didn't answer. For 24 tense hours, the team had no idea what had gone wrong. Then, on the next sol, Spirit responded. Just once. A faint beep, not data. Just a whisper of distress. Spirit had entered fault mode. She was still alive, but barely. The engineers scrambled. If it was hardware, the mission might be lost. But if it was software, there was still hope. Spirit was commanded to transmit engineering diagnostics, and what came back was revealing. A glitch had caused her to stay active during sleep mode, draining her power, overheating her batteries. Then, on Sol 20, she ignored a direct shutdown command. She was supposed to power down. She didn't. Something was deeply wrong. One theory: a reboot loop, a self-restarting cycle caused by a system fault, each reboot triggering the same error over and over again. The cause: corrupted flash memory. To break the loop, engineers triggered a backup boot path that bypassed the flash storage entirely. It was a long shot, but it worked. They found the flash memory bloated, with thousands of old files. Data from Spirit's flight to Mars? Unneeded. Deleted, reformatted, clean. And then, on Sol 32th of February 6th, 2004, Spirit came back, fully operational. Back from the brink. To Spirit and her tools, Martian rocks weren't just debris to analyze. They were ancient capsules of history, each one holding secrets of the planet's past environment. The only question was, which one to open first? Nearby was a rock named Sashimi Dash, an easy drive, and at first glance, a tempting choice. But there was a problem. Its surface was coated in dust, which would have interfered with clear observations. Worse, it was pitted, not ideal for Spirit's grinding toolset. Fortunately, there was another candidate. A football-sized rock with a flat, clean surface and far less dust. It was more challenging to reach, but so well suited to Spirit's instruments that it couldn't be ignored. Spirit set off into the wide-open floor of Gusev Crater. She rotated 40 degrees, moving cautiously in short arcs for just under a meter, then turned to face the rock and made 4 more precise moves, each just under 2 meters long. This level of detail might sound excessive, but navigating the rocky plains of Gusev demanded this kind of precision. Gusev Crater itself spans 166 kilometers in diameter and dates back between 3 and 4 billion years. Some scientists believe it was once filled with water, fed by the enormous Ma'adim Vallis, a Martian outflow channel over 700 kilometers long, vastly larger than Earth's Grand Canyon. That theory of Gusev being an ancient lakebed was one of Spirit's key missions to investigate. To do that, she turned to her rock abrasion tool, or RAT, the device designed to grind and brush Martian rocks. Just 10 centimeters long, the rat used a spinning wheel coated with diamond dust and resin, reaching speeds of 3,000 revolutions per minute. This allowed it to bore a hole into the rock, 45 millimeters wide, 5 millimeters deep. The rat also had 2 brushes to sweep away any remaining dust, so Spirit's science tools could get a better look. For all this, the rat only used about 30 watts of power, less than a light bulb, which mattered greatly for a rover that had to conserve energy. After the grinding was complete, Spirit's other instruments moved in. The newly exposed rock surface allowed the microscopic imager to study it more clearly, revealing its true composition. Before performing any grinding, Spirit first returned microscopic images and readings from her Mersbauer spectrometer. These were taken from a rock called Adirondack, and they were groundbreaking. This was the first time such detailed scientific investigation had ever been conducted, not just on Mars, but on any other planet. The results were promising. They suggested that Adirondack contained minerals like magnetite, olivine, and pyroxene. Minerals not too different from the volcanic basalts found on Earth. But to be sure, Spirit had to drill. On February 6th, Sol 34, she deployed her rock abrasion tool, the RAT, to grind into Adirondac's surface. The fresh surface revealed a story billions of years in the making. Spirit's instruments confirmed it. Adirondack was indeed volcanic basalt. And it wasn't alone. Other rocks on the Gusev Plains shared the same composition, rich in pyroxene, plagioclase, olivine, and magnetite. Geologists called these picritic basalts, akin to Earth's own basaltic komatiites. But there was something more. Some rocks, including Adirondack, showed slight alterations, as if thin films of water had once passed through, mineralizing the stone over time. And one more clue stood out. Gusev's rocks were easier to grind than expected. That softness could be another hint that water had a hand in shaping them. Then came a new target. On March 5th, Spirit made her way to a rock named Humphrey. It was a dark volcanic stone, about 60 centimeters tall. Using her rat, Spirit ground just 2 millimeters into Humphrey's surface, and what she revealed was striking. Cracks lined with minerals that had crystallized from water. Another whisper from the past, that water had once flowed through this ancient land. And with that, Spirit moved closer to one of the core questions of the Mars exploration program. Did life ever exist here? If humans are ever to settle on Mars, answering that question is vital. But Spirit's journey wasn't done. On Sol 65, March 11, 2004, she began the trek toward Bonneville Crater. Inside it lay her old heat shield, ejected weeks earlier during her descent. Bonneville wasn't very large, around 210 meters wide, just 14 meters deep, with a rim barely 6.4 meters tall. Its proportions suggested it was likely a secondary crater, formed by debris kicked up from a larger impact elsewhere. It was clean, untouched by water erosion. But despite the hype, Bonneville offered no exciting targets. So Spirit didn't descend into its depths. Instead, she turned towards the Columbia Hills, a feature she had glimpsed way back on Sol 1. On the way, she crossed another crater, La Hontan, smaller than Bonneville, just 55 meters across, but more dangerous. On its southwest edge lay a long sand dune, a threat to Spirit's delicate wheels. One wrong turn, and she could be trapped. The team steered her carefully around it. Even with hazards like these, Spirit's route was mostly straight, largely autonomous, with engineers stepping in only when the terrain became too complex. By Sol 159, Spirit had arrived at the base of the Columbia Hills, a region called West Spur. But a new issue emerged. Spirit's front right wheel began drawing 3 times its normal power. Something was wrong. Either debris had jammed the wheel, or the lubricant inside had congealed. Thankfully, Spirit had heaters embedded in each wheel assembly. They were designed to handle exactly this kind of failure. But to prevent permanent damage, the team made a tough decision. Spirit would now rely mostly on her 5 good wheels, dragging the 6th behind. That drag would have to be accounted for, especially on steep or unstable terrain. There, she'd have no choice but to power all 6. On Sol 174, Spirit began what the team called a 3,000-meter tune-up. It was a series of adjustments meant to prepare her for the next phase of the mission, designed to help her travel another 3 kilometers across the Martian surface. One of the key issues? Her front hazard avoidance cameras were starting to struggle. Spirit had developed a 2 to 3 centimeter inaccuracy when predicting the exact location of her targets. To fix this, the team had her pose her robotic arm in multiple positions, then use stereo images to refine her targeting accuracy. Next came diagnostics on her troubled front wheel, followed by lubrication procedures to help restore smooth rotation. She also ran visual odometry tests, allowing Spirit to track her own movement more accurately and navigate with improved precision across the rocky Martian terrain. And then came something new. Spirit entered her very first deep sleep mode. This wasn't just a nap. She powered down almost entirely overnight, even switching off systems like survival heaters and idle electronics. It was a major energy-saving step, essential for conserving power over the coming Martian sols. But it came with a risk. With the heaters turned off, Spirit's mini-thermal emission spectrometer might not wake up again. To be safe, Spirit conducted 2 final observations using that instrument, just in case. Throughout all of this, her solar panels were carefully tilted toward the winter sun, maximizing energy collection and helping her fight back against dust buildup and the fading light of the Martian season. Once the tune-up was complete, Spirit resumed her journey, spending the following sols studying a wide variety of rocks scattered across the Columbia Hills. Among them were formations named Clovis, Ebenezer, and Lutefisk. Then on Sol 188, Spirit found a clever solution to her front wheel issue. She began to drive in reverse. Pulling her stuck wheel rather than pushing it reduced resistance, eased the motor's burden, and helped extend its operational life. It was a simple, elegant fix, an example of how ingenuity and adaptation were keeping Spirit alive. A brief solar conjunction followed. When Mars moved behind the Sun from Earth's perspective, blocking communication, but once that window passed, Spirit resumed her mission and set course for the summit of Husband Hill. The hill stood roughly 107 meters above the Gusev Crater plains, a commanding rise that offered spectacular views. Its southern slopes were lined with a striking albedo feature, dark, rolling sands, almost like dunes on Earth. They're part of what gives Mars its textured, mysterious look when seen from orbit. By Sol 344, Spirit had reached a good vantage point, firmly in position to continue her scientific campaign. 344 sols. That's almost 4 times longer than her original 90-sol mission. And still, she kept going. Collecting data, imaging rocks, telling the story of Mars one sample at a time. But how much longer could she keep it up? As the days passed, Spirit approached the first anniversary of her landing on the Red Planet. To mark the occasion, she studied a rock called Champagne. Yes, even robots celebrate milestones. She examined it in solitude, armed with her full science payload. After the measurements, Spirit's engineers discovered a minor short circuit, just 0.1 volts. It didn't pose an immediate threat to her operations, but it did make her slightly more vulnerable to future electrical issues. Still, Spirit was performing well. She climbed carefully, navigating the soft, dusty slopes with caution. Her route planning became more complex, largely because of a growing concern: dust accumulation. The atmosphere was carrying more of it than usual, and some had settled as a thin layer on Spirit's solar panels. That meant every move had to be precise. Every watt had to be conserved. As she pressed on toward Larry's Lookout, a rocky outcrop along Cumberland Ridge, Spirit paused to study 2 small rocks, Peace and Alligator. Then she aimed her camera toward a far more distant target, one she would never reach: Phobos. Mars' largest moon, just 26 kilometers wide, destined to crash into the Martian surface in about 10 million years. With those imaging tasks complete, Spirit began to cross Cumberland Ridge, but didn't get far before making a surprising discovery. NASA engineers noticed she had stirred up a strange patch of soil during a maneuver. The location was named Paso Robles. and it was unlike anything Spirit had seen before. The soil at Paso Robles was packed with salts and unusually high levels of phosphorus. NASA's reaction? We're still trying to work out what this means, but clearly with this much salt around, water had a hand here. It was a fortuitous discovery and a crucial new piece of the puzzle. Just one more step in Spirit's extraordinary mission to uncover the watery past of Mars. To complete its journey to Larry's Lookout, Spirit deftly reversed large sections, which helped relieve pressure on the failing front wheel. Instead of pushing the struggling wheel into the ground, reversing the rover up the slopes dragged the wheel across the surface, saving energy. From Larry's Lookout, Spirit took this panorama on Sol 413. To the right, we can see Spirit's tracks. To the left, a rocky outcrop, part of the Cumberland Ridge. Beyond that lies the Tennessee Valley. The image was made with 108 frames, each composed of 5 images taken through Spirit's different filters, which created an approximate true color image. In the center of the image, 200 meters away and 45 meters higher in elevation, stood the summit of Husband Hill, Spirit's next destination. It was a difficult and energy-consuming journey, but Spirit had a chance encounter that greatly improved her prospects. On Sol 421, a Martian dust devil swept over the rover, clearing a year's worth of dust buildup and increasing her solar panel efficiency from 60% to 93%. Over the next 160 sols, Spirit tackled her way to the top. The increase in energy meant she could upload her data every sol via the Odyssey orbiter, capturing information en route on samples like Paso Robles 2, Big Clod, Paso Dark, Methuselah, Keystone, Pittsburgh, Independence, and Franklin, without filling up her limited memory. On Sol 581, Spirit reached the first summit of Husband Hill. But our hard-working rover had no intention of standing idle. She took a full 360-degree panorama composed of 653 images, and for the first time, imaged her own deck. The panels were clean, gleaming, a symbol of resilience. During the nights on top of Husband Hill, Spirit imaged both of Mars' moons, Phobos and Deimos, to measure their orbits more accurately. In that same panoramic image, you can see McCool Hill and Ramon Hill off in the distance. McCool Hill was to be Spirit's winter destination, a place where she could park and tilt her panels toward the sun, maximizing energy through the dark months. But she never reached it. So let's continue with Spirit's journey to see what she could achieve in the final 2.6 kilometers of her life. So on the descent of Husband Hill, Spirit was able to collaborate with the Hubble telescope to help calibrate data using atmospheric opacity readings, a sky survey, and calibration target images. These helped improve the accuracy of Spirit's measurements. Incredibly, Spirit's capabilities were upgraded multiple times in her life, despite being 142 million kilometers away from her engineers. The multitasking rover installed a software update while climbing Husband Hill, which gave her the ability to drive segments autonomously. Another update on Sol 1067 allowed Spirit to decide if and when to upload images, and whether to extend her arm to examine rocks. Spirit was gaining independence as she matured. But there was still one decision NASA made from Earth. As Spirit descended Husband Hill, 2 rocks appeared before her, Comanche and Miami. Comanche was chosen, and it turned out to be a rich target. On Sol 690, Spirit discovered that Comanche was composed of 25% magnesium iron carbonates, 10 times higher than any previous rock studied on Mars. Carbonates matter because on Earth they form in the presence of water, but dissolve in acidic environments. so the presence of so much carbonate suggested Mars once had water that was neutral, stable, even hospitable. Maybe a place where primitive life could have existed. It was a stunning discovery, but Spirit didn't stop, and by Sol 744 reached her next checkpoint, a layered, weathered plateau called Home Plate. Here, Spirit found bizarre formations, rock features shaped in ways that strongly hinted at flowing water. But it was time itself that was shaping Spirit. In March 2006, as Spirit was approaching the north-facing slopes of McCool Hill, disaster struck. Her right front wheel failed completely. NASA tried everything. Back on Earth, the JPL team tested simulations of the malfunction, but nothing worked. From then on, Spirit could only drag the locked wheel behind her. Winter was also closing in, and sunlight was fading. With time and energy against them, NASA made a hard call to abort the journey to McCool Hill and instead divert to a closer slope. Spirit parked on an incline of 11 degrees, just enough to catch the sun's rays. Her new home was named Low Ridge Haven. For the next 8 months, Spirit hunkered down. She took images of her surroundings, still doing science. In one image, engineers noticed something unusual. 2 dark, isolated rocks. Likely iron meteorites. They were named Zhongshan and Allen Hills, after the Antarctic region where famous Martian meteorites have been found, including one in 1996. The meteorite that some believed might contain fossilized extraterrestrial life. Once the Martian winter was over, Spirit had far more energy to use, and she ventured out once again. In March 2007, Spirit unintentionally uncovered something extraordinary. While dragging her failed wheel through the soft red Martian soil, she gouged a trench in the ground. Beneath the rust-colored dust was a streak of brilliant white. It was silica, a highly concentrated deposit, unlike anything Spirit had seen before. Silica like this typically forms in 2 types of environments on Earth, either from hot springs, where dissolved silica is deposited as water cools, or from fumaroles, acidic steam vents that strip away minerals, leaving behind pure silica. Both are key habitats for microbial life, which meant Spirit's accidental trench might be the most important one ever dug on Mars. Over the following months, Spirit explored the region around Home Plate, studying soils and rock layers. Then, in June 2007, she received another unexpected blessing. A dust-cleaning wind swept across her solar panels, restoring her energy output from a low of 120 watt-hours back to over 600. It was like breathing fresh air again. On November 6th, Spirit navigated to the western side of Home Plate and took another panoramic image. NASA published it as an astronomy picture of the day. At first glance, it looked like a typical Martian landscape. But then, people noticed something strange. A tiny, shadowy shape on the horizon, dubbed Little Bigfoot. Was it a rock? An illusion? Almost certainly. But it served as a powerful reminder of just how alien and lonely this world truly was. To the right of the image, Spirit's own tracks mark the dusty ground, tracing her long journey from Husband Hill. And now, she was just a few hundred meters from what would become her final resting place. Martian storms were growing stronger. Dust blanketed her solar panels. Winds swept across the land, dimming the already faint sunlight, blocking up to 99% of the light from reaching her panels. Spirit's power was dwindling. She was generating just 128 watt-hours, less than the 150 she needed to keep her systems warm. If the heaters failed, her internal components would begin to freeze. Then, a moment of hope. 2 small, dust-clearing events swept her panels. Her energy output climbed back to 372 watt-hours. Enough to charge her batteries and move again. But time is merciless. By April 2009, Spirit began to suffer memory losses. Unexplained data gaps. Her mind was slipping. And then, just 4 meters from safety, on Sol 1892, Spirit became stuck. She had driven into a soft, dusty patch known as Troy. Beneath her wheels lay a mineral called jarosite, an iron 3-sulfate with almost no cohesion. She couldn't gain traction. She couldn't escape. NASA engineers tried everything. Back on Earth, they replicated the terrain at JPL, ran simulations, tested every maneuver. But nothing worked. On Sol 2155, NASA declared it official. Spirit's journey as a mobile rover was over. She was now a stationary science platform. Even stuck, she kept working. She studied Martian soil, analyzed the thin atmosphere, and captured a final sweeping panorama from her new location. Her robotic arm still functioned perfectly, and she used it to stay active. But the final Martian winter was approaching, and it was brutal. Each day the sunlight grew weaker, the temperature fell, and her power dropped further. By the end, Spirit was running on the thinnest thread of power. Her systems were holding on, just enough to survive. And then, one quiet morning, around her 2200th Martian sunrise, she fell silent. She came to rest beside home plate, with 2 broken wheels, a drained battery, and a story written in dust and light. Across 2,088 sols, she traveled 7.7 kilometers across the Martian surface. She returned more than 128,000 images, and helped us reimagine the history of water and the possibility of life. And her legacy lives on, in perseverance, in curiosity, and in every explorer who follows. Her story began with a young girl, Sophie Collis, an orphan who once looked up at the sparkly sky and made a wish. It was dark and cold and lonely. At night, I looked up at the sparkly sky and felt better. I dreamed I could fly there. Spirit did. For all of us.